One way to find the resultant vector, magnitude and direction of two forces acting on an object, is to convert each vector to rectangular form, an x and y coordinate, then add the x coordinates, add the y coordinates, and you've got the coordinates of the endpoint of the resultant vector. And you can find its magnitude as its distance from the origin, find the angle that it makes by using inverse tangent, and all that. But I thought I'd show you another way to do it using the law of cosines. Okay, so here's the first vector, magnitude of 35 in a direction of north 45 degrees east. So this is 45 here. And that means this angle is 45. The second vector, we're going to go tail to head, is, see these green dashed lines? That gives you a north-south line and an east-west line. And so we're going south 30 degrees east for the second vector from the head of the first vector. And that takes you down to a magnitude of 55 down to this point somewhere down here. And we want to find the length of this side is the magnitude of the resultant vector. And then we'll talk about the direction of that vector in a second. Notice that this green dashed line and the x-axis are horizontal, so they're parallel. So this vector right here is a transversal, and two parallel lines cut by a transversal, alternate interior angles are congruent. So this is 45. Since this is a 90-degree angle here, this is also 45. So this angle is 75 degrees, and we can use the law of cosines because we've got a side angle side relationship. And so here's I called this little c here, law of cosine, c squared equals 35 squared plus 55 squared, etc. And that all translates to 57.04 pounds. That's what this is right here. Now, what about the direction angle? Assuming we're going to use north, south, east, or west, we want to find the size of this angle right here. We can use the law of sines to find this angle, which there it is right there, 68 degrees. If we subtract 45, that'll give us what, 23.65 degrees. That's the size of this little angle right here. If we subtract that from 90 minus 23.65, I'll leave that calculation to you, but whatever that ends up being, 60 something, we can say the direction angle is south, whatever, 60 something degrees east. This angle right here. Okay. There you go. That's just another way to do it. You have to decide which is easiest in the context of the problem, converting to rectangular coordinates or using the law of cosines. There you go. Hope that helped. If you have any questions, post a comment.